All right, thank you for joining me today. We're going to be looking at converting measurement units using ratios and or proportions. So the first thing we're going to do is just look at what units are out there. These are your customary units. They're known as customary units because they're the ones that you're probably the most familiar with here. Feet, inches, yards, miles, and of course those are your units of length. You also have your units of weight over here, which are things like pounds, ounces, tons. Then lastly, you have your capacity, which are your cups, pints, quarts, and gallons. We're going to be using this to revert back to as we work through some problems here. But before that, let's go ahead and take a look at your metric units. Your metric units aren't, you really won't use these as much here in the United States. However, they are used around the world. You can see the measurements in length are things like centimeters. You will see that on our customary ruler. Centimeters, meters, there are meter sticks that you're probably familiar with as well, and kilometers. Then you have mass, which are grams, kilograms, things of that nature. You also have a metric ton. And then finally your capacity, things like liters and kiloliters. Okay, so we're going to look at converting each of those types of units today. And we're going to start with the customary units. Our first example here is going to be converting 12 feet to how many yards. Okay, so if we revert back, we're going to be looking at feet and yards here. Right now we're looking at 1 yard equals 3 feet. We're going to use that to help us set up a proportion to solve. Now, we learned how to do proportions on an earlier lesson, but I will also show you how to do it here as well. So going back to our example here, we know that 3 feet equals 1 yard. So at this point, we're going to set that up. 3 feet over 1 yard. Now, the key to setting up an appropriate proportion here is keeping both of your fractions, when you set it up, with the same units. If you have feet on top, the other fraction must also have the number of feet on top. And you'll see that I'll do that here. So in our problem, we know our conversion is 3 to 1. In our problem, they want us to figure out how many yards 12 feet are. So that means we need to put 12 on top on the other side. And of course, our unknown is the yards. That's where you'll use your variable, x. Okay? Now, you can see that I've set it up so that the feet, both these measurements on top are both feet. Both the measurements on bottom will represent yards. However, one of them we don't know, and that's what we're going to find. Now we're going to use the process of cross multiplication again. Here you will cross multiply 3 times x and 1 times 12. All right, and when you do that, it'll set up an equation. So we'll start with 3 times x. When you multiply 3 times x, you will get 3x. Then we will multiply 1 times 12. When you multiply 1 times 12, that gives you 12. Nice and easy multiplication there. When you have your equation set up, this means 3 times x. To solve that, you're looking for what value multiplied by 3 gives you 12. You can probably think about that in your head. However, algebraically and mathematically, what we'll want to see you do is solve this using inverse operations, which means inverse of multiplication, use division. And what you do to one side of the equation, you have to do to the other, which is why you see me dividing the other side by 3. Now again, you probably already knew that 3 times 4 would give you 12. However, you can see here that 12 divided by 3 is now going to also give us that solution. So our solution here is going to be 4. All right, so let's look at the next example then. 18 feet equals how many inches? So let's revert back. We're looking for feet and inches to our chart. And we see how many feet equal, 1 foot equals 12 inches, which that conversion is right here. So that is our initial part of our proportion. So let's go back to our example. All right, so we're going to be looking at 12 inches equals 1 foot. So 12 to 1 ratio there, 12 to 1. So again, when we set this up, we have the inches on top and the feet on the bottom. So as we set up our second fraction, we'll want to stick to that. So now we're looking for 18 feet equals how many inches? Well, again, feet go on the bottom. So 18 will need to go to the bottom of our second fraction. What goes on top? Well, again, we don't know, so we're going to use that x again as our variable or our unknown. So again, both of these will represent inches on top and on bottom. They will both represent, as you can see, they both represent the feet. And you're going to use your cross multiplying again. So 1 times x and 12 times 18. So I'm going to jump over here to the side. That's going, 1 times x is simply going to give us x. And what that means then is once we multiply 12 times 18, we'll actually have our answer. So off the side here, we'll do that math. 12 times 18. 8 times 2 is 16. We'll carry the 1. 8 times 1 is 8, plus 1 is 9. Hold the place with a 0 or a blank. And then multiply 1 times 2 and 1 times 1. Whoops. And we go ahead and add. 6 plus 0 is 6. 9 plus 2 is 11. And 1 plus 1, carrying the 1, would give you 2. So you find that it's 216 inches. Okay. All right, the next couple of examples, we're just going to continue to look at just the different types of customary units here. Now we're looking at cups to fluid ounces. So cups to fluid ounces. Let's check out where that's going to lie on our chart here. Our cups to fluid ounces are right here. Cups, 1 cup to 8 fluid ounces. Okay, so 1 to 8 or 8 to 1, depending on how you want to write it. Now again, I didn't mention that earlier, but you can write it either way. You can write it as 1 over 8 or 8 over 1. That will affect your second fraction, however. So keep that in mind. So going back to our example here, 8 cups equals how many fluid ounces? Well, we just saw that it's 1 to 8. So 8 fluid ounces equals 1 cup. So again, on top we have our ounces, on bottom we have our cups. So we need to set up our second part of our proportion that same way. So do we know how many fluid ounces we have? No, that's what we're trying to find. So that's our variable x. All right, we know how many cups we have. We have 8, so that will go in the denominator. And you can see then you're set up to cross multiply again. Cross multiplying here again, 1 times x is going to give you x. And this time a bit easier multiplication there. We're going to have 8 times 8. So our equation will be set up as 1x equals 8 times 8, which is 64. So 64 fluid ounces. All right, the next one down there at the bottom, you see you have gallons to quarts. All right, gallons to quarts. Our conversion there is right down here at the bottom. 1 gallon equals 4 quarts. So 4 quarts to 1 gallon or 1 gallon to 4 quarts, depending on how you would like to set that up. So 1 to 4. All right, so we're going to set that up as 1 over 4. So that's gallon over quart. So as a reminder, you need to make sure that that second fraction keeps that same order of gallons over quarts. If you chose to flip that over and do 4 to 1, again, the second fraction would have to also represent that. It would have to be quarts over gallons. So make sure you pay attention to that, otherwise it'll get all mixed up. So we're looking at 8 gallons. So we know the gallons, which would be on top, 8. However, we're looking for the number of quarts, which we don't know, x. And then we'll cross multiply. 1 times x, 4 times 8. So again, you can see after you multiply, 1 times x sets you up for your solution again. 4 times 8 is going to give you 32. All right. Next examples here, a couple more. Looking at ounces to pounds. So now we're looking at our weight. So we're going to start with 64 ounces equals how many pounds? So let's find out what that conversion is. All right, that conversion is right here. 1 pound equals 16 ounces. All right, so 1 to 16 or 16 over 1. So going back to our example, we have 16 ounces over 1 pound. So that's ounces. I'll put an O for ounces and a P for pounds. We need to make sure our second fraction represents that in the same order. So we know how many ounces we have. We have 64 ounces. So that's going to give us 64 on the right side. Over what? We don't know. So we put a variable. And again, you can use any letter you want. I just choose to use X. And then we're going to cross multiply. X times 16 and 1 times 64. When you do that, you're going to end up with 16 times X, which is 16X, and 1 times 64, which is 64. And hopefully you're starting to see a pattern with these. You either end up finding your solution or you may end up having to divide. This one will end up having to divide. This is 16 times X, which means division will undo that multiplication. And what we do to one side, we have to do to the other, as you see here. So we're looking at 16 divided by 16, which is simply just X. And then off to the side, we can figure out what 64 divided by 16 is. 16 into 64, like so. If you're not exactly sure, you may have to multiply a couple times to figure out how many times it goes in. You can do that off to the side. If you think it's around, we know it's going to be less than 6. If you think it's around 3 or 4, go ahead and multiply like so, off to the side to test, to make sure. And you can see here that when I multiply 16 times 4, you end up getting 64. So it actually is 4. It's better safe than sorry when it comes to math, because it's very easy to miss some little details along the way. And so your solution here is going to be 4 pounds. All right. And then our final example in the customary units is tons to pounds. So let's go back to our chart here. And it looks like 1 ton equals 2,000 pounds. So you're looking at 1 to 2,000. 1 ton to 2,000, or 2,000 to 1. So we'll set that up as 2,000 pounds over 1 ton. And again, that can also be 1 over 2,000. Completely up to you. Set equal to. Again, make sure you stick to that same order. We know we have 5 tons. However, tons in this case are actually on the bottom. These are your pounds on top. Your tons are on the bottom. So we're going to put 5 at the bottom. We don't know how many pounds. That's your X, or your unknown. So once again, we are cross multiplying. 1 times X and 5 times 2,000. So in this case, you're going to end up with 1 times X, which is X, and 5 times 2,000, which you may have to do off to the side if you're not sure. So we'll multiply that out. 3 zeros and a 10. All right, so it looks like you end up with 10,000 pounds. All right. This is just one strategy you can use. I like to use proportions because it is a process that you use quite often in other places. As you've probably seen in 6th grade, you can use proportions with percents as well as other parts of ratios. The next portion of the lesson here we're going to look at are metric conversions. Now the nice thing about metric conversions really is it's movement of a decimal only. So what you're looking at here is a good little acronym you can learn. King Henry died drinking chocolate milk. It's to help you remember what each of those measurements mean, okay, or what they represent. All right, so K is kilo, H is hecto, D is deca, and then you always want to leave a space right here where I said leave a space, and that is because when you're moving your decimal, and I'll show you in a moment, it can be affected if you don't. Your answer can be affected. But then you go into your smaller units. These are all your larger units, and these end up being all your smaller, okay? And you may be familiar with kilo, probably not so much hecto or deca, but kilo you'll see every now and then, like kilometer. It's very similar to a mile, okay? You've definitely seen centimeters, probably millimeters as well, because of rulers, things you've used in math before, possibly science. All right, so let's look at some examples of how you'll set this up, and I'll just show you really quick. If you use the acronym, when you get ready to solve a problem, you will write them in this order. K, H, D, leave a space, then DCM. Okay, and again, each of those letters represents a decimal place. Okay, so we'll look at the next portion here and work through a couple of examples to show you how to move it around. So 20 millimeters. And again, the type of measurement you're dealing with does not matter. You can still use this same strategy. So whether you're using grams, meters, liters, in the metric system, it's not going to matter. You'll still use the same strategy. So I'm going to go ahead up here at the top and write out King Henry died, space, drinking chocolate milk. See, it's nice and easy to remember. Kind of silly, but easy to remember. So we're looking at 20 millimeters equals how many meters? Well, notice we don't have meters on here. Well, that's because there's a standard starting point. Your starting point units would be things like meters, liters, or grams. Okay? And each of these, meters, liters, or grams, are why you left that middle space where we left it, right there. Okay, because that's where you'll put your standard base unit. And that's what I call it, a base unit, because everything else works off of that. However many grams is going to be determined by the prefix, deca, hecto, or kilo. And then how many liters, same thing. So we're going to go ahead and put meter, or M, right there, because that's going to represent meters. All right, now don't get confused, because this M, again, represents the prefix milli. So if you want to actually write out meter to remind yourself, you can do that as well. All right, but that goes right there in the middle, and that becomes a decimal place as well, and that's why we leave it blank. So now what you're going to do, I'm going to write 20 underneath our little strategy up there of the letters, and we're starting at millimeters and we're moving to meters. So where are millimeters? Well, they're right here. Okay, what we're going to do is count how many places it takes us to get to meters. All right, so starting here, it's going to be 1, 2, 3 places. It takes us 3 places to get to meters. Well, that's exactly how many times in the exact direction you're going to move the decimal in the number 20. So the decimal in 20 is at the end. We're going to move that decimal the same number of places. So we're going to move it 1, 2. Now I know that there's not a third place, but you have to include it by adding a 0. And you'll see by doing that, you end up with 0.020. Now you can write it out as 0.020, and that'll be perfectly fine. However, this 0 at the end is not really necessary, so if you don't want to leave it there, that's fine. However, if you leave it there, it's still correct. So we're looking at 0.02 meters, okay? So let's look at our next example there of kilograms and milligrams. Again, we're using the same strategy. King Henry died, blank, drinking chocolate milk. And this time our base unit will be what? Grams, because you can see kilograms, milligrams. So we just put a G in there to represent another decimal place, which would be our base unit decimal place. And a similar strategy, we're going to move our decimal the same number of places that it takes us to get from the milligrams, or the milli prefix, which is right here, to the kilo, or kilo. All right, so we got quite a ways to go. You can see we're going to have to move it quite a bit. So that's 1, 2, 3, 4, 5, 6 places that it takes us to get there. Now notice I moved it to the left. Our decimal is right here in 0.032. It's very tempting to just move it to the right. However, you have to move it in the same direction that you went up here. So in this case, we're going to take our decimal and move it 6 places to the left. So that means we're going to have to add place values as we go. So I'm going to just leave little arcs along the way. That's 1, 2, 3, 4, 5, 6 places. And you can see each of these little arcs will get a little 0. All right, and I'm not exactly sure off the top of my head what that actually is as a number or how you would read it, but it is quite a decimal. It's a very small number, which should tell you quite a bit about milligrams. They're very, very small. All right, the next example we're going to look at, again, just sticking with the same thing here, some metric conversions. You can see this time it's meters. So again, King Henry died, blank, drinking chocolate milk, meters, we'll just say right there. If you want to write it out again, because it can get confusing with the milli prefix over there, you can write it out if need be. But this time we're looking at 3 kilometers. So we're going to write 3. All right, and we're going from kilometers to centimeters. Well, kilometers is here, centimeters is here. So we're going to count it out. That's going to be 1, 2, 3, 4, 5 places that it takes us to get to centimeters. So where is the decimal in the 3? Well, the decimal in the 3 is at the end. So again, we're going to, or to the right of it, we're going to move that decimal the same number of places and in the same direction. So we moved 1, 2, 3, 4, 5 places. 1, 2, 3, 4, 5. And again, I use these little arcs as a reminder to go back and place some zeros. So that looks like it's going to give us 300,000. That one we know, 300,000. All right, and then the last example here is going to be, again, just working with centimeters and kilometers, just to show you how you would go back the other direction. So King Henry died drinking chocolate milk. You're looking at meters again as your base unit. So this time we know we have 85 centimeters. We're going to start at C and move to the K. So 1, 2, 3, 4, 5 places to the left. The decimal is at the end of the number 85 or to the right of it. So we add that in and count that number of places to the left, which was 5. 1, 2, 3, 4, 5. The decimal would go right there, and these would be filled in with zeros. All right, that is your lesson on converting unit measurements.